Short-lived. I got so like distracted that I went to guest list for free, and then when I got here, they're like, "Oh, by the way, we're having a surprise party, so we're trying to make a cake." I'm like, "Really? Thanks for the notes, guys." We went shopping for a little bit. I went home with some bread and a pie. And then I had to for a little bit.
You're the only one who wants the front row view, huh?
Oh, yeah.
Okay, welcome for the final week of Engineering 120, electrical engineering portion. Just a reminder, I put up here on the Elmo. Everybody by now should have asked your famous question. By the end of the week, by Friday, you'll have the summary of this week as well as the presentation that you're preparing. Any questions about this? Be sure that you sign the attendance roll coming around, and if somebody would volunteer to run it across the hallway, I'd appreciate it. Okay, before we get into the main part, to address a couple of questions that have come up. Some have asked about kind of what's going on at ISU, kind of, why do people like I teach classes at ISU or others when I could be engineering doing something else? And so I just wanted to try to kind of educate you in a little bit about how things work at the university in terms of engineering education and the process of doing engineering work. And so I put together a brief model, if you will, of what I call a corporate business model. And basically, in the corporate world, it's very competitive. We make our choices and our decisions based upon price, innovation, and performance. And so there's always a need for those who are engineers, if you will, if it's an engineering company. The engineers, customers come together, they're going to make decisions whether to buy or to purchase your product. There's partnerships in the industry. And who owns the corporate, who owns these companies that come to work to town that hire us? Well, they're owned by stockholders and bondholders. And who are these people? Well, they're us collectively, or us globally. Nowadays, China actually owns a very significant part of the United States. So we are, in a corporate sense, beholden to all these people who actually have ownership in these companies. And it's important that a corporate company make profits. Profits is having something left over at the end. And you know that when you budget your monthly budget. And so the dividends or the profits, they go back to the owners. They go back to developing new products and new services that we all purchase and buy. Now, as time goes on, we need to do something that's improved. We need to always come up with something that's new and innovative. And so here in the corporate world, the risk of doing this is pretty much shared by the owners, and a little bit is shared by society. So I want to just kind of compare that with what happens at a university setting. The university can be thought as a business itself, and it's a very competitive business. We compete for you. You are our customers, and we have to go out and encourage and entice students to come in with us to participate in this enterprise. Who owns ISU. We all do. It's owned by the taxpayers. Probably more importantly, it's your parents that own it. I mean, you guys are just starting. You don't pay very much taxes yet, but you do. As you buy everything, you pay sales tax. But the taxpayer is owned. How about the risk and the benefit? Well, this is shared by all the state of Idaho, or Pocatello or Idaho Falls. I mean, here what happens at ISU is an interest to all of us. So what goes on here at ISU? Well, obviously you're here as students, and then there's some of us that are here as faculty. And what do faculty do? Well, faculty have three main things that they do. They teach students, like a class like this. Secondly, they're out in the community helping to solve community things, one or another, as a service to the community. And they also conduct, along their area of their expertise, which is called research. And what is this research? Well, it's the process of trying to innovate. You try new ideas and new things. And so the newness of the ideas in the university setting can be very, very new. They don't have to pay back a dividend very immediately, and the risk is shared with the whole society. So in general, in a university setting, you're likely to have basic research that has very innovative ideas being performed and done. And that's the advantage to students. When students come here and go to school, you spend your first few years learning the basics. And then as you develop in your skills and your abilities, you graduate with an undergraduate degree, and then you begin to participate in more research opportunities. But also research opportunities can occur at the undergraduate level, and that is happening as well. So anyhow, the point is here with the university that ABET accreditation is a guiding star for us in terms of making sure our business is meeting the needs of our customers, which is you guys. And so there was a question about the ABET accreditation, and so I just wanted to make sure that you knew that of all the things going on at ISU, ABET accreditation is definitely the top of the list, because that enables us to produce a product that the employers out there will be interested in and will be competitive. No doubt about it that things are competitive. We have to compete for you. We have to compete, for those students that may go to BYU Idaho or Utah State or Boise State. And there's also no doubt about it that we are in the interest in the business of trying to increase our business activity. That is in enrollment or in the amount of research that takes place at the school, that the school does for others, that the students get to be involved in. And no doubt about it also that the resources, from the state or from the community are finite. It's not a bottomless, fund that we can all draw on. So there's lots of things that are at play, and that it's a continual process of working within, these constraints. But I just wanted you guys to know that, because there are some questions about, what's happening and so forth, that, it's a dynamic process. Accreditation is very important, and they'll be there. And we're all working together to accomplish a lot of good stuff. Okay, now that I've said that and answered a couple of questions from you, I'm going to turn the time over to Gerald Rowan. He works for Idaho Power. Most of you probably pay for his salary, or your parents do. He's going to talk to us about what I refer to big electrons, those that are used to generate power for us. And that's a very important topic regardless of which engineering discipline you're in. By the way, most of these are mechanical engineers, some civils, And I think there's one computer science, but not a double E in the batch yet, right? So if you're interested in reforming yourself and become a double E, put an asterisk by your name on the enrollment or on the thing. Okay, so I'll hand in the microphone and then you can ask him all the questions.
Put this up here and it just works just fine, huh?
Just works good.
Oh, okay. Well, thanks, Kenyon. Comments about the type of engineer. Yes, my degree's in electrical. I have two brothers, another one that's an electrical and one that's a civil, and he reminds me he's the only civil one in the group. And I have one son that's a mechanical engineering student here at ISU. I couldn't talk him into going into electrical. So, Kenyon, I don't know how much I'm going to be good for the conversion process here, but it's good to have all types of engineers. I mean, on a day like today, I'm glad that some mechanical engineer designed that HVAC system that's churning out the heat and keeping the buildings warm. I'm also glad that some electrical engineer supplying the power to run it. So there is a joint effort there on that. Okay, so this presentation is showing up then apparently. Everybody's able to see that, I guess. Okay. I have a little presentation here talking about being an engineer, and I'm going to talk a little bit about Idaho Power, as I go through this a little bit too. Of course, we're all prejudiced, or we wouldn't be, in the engineering field. So we think it's a good field, be it electrical, mechanical, civil, or whatever. But being an engineer, it is a good profession. I've enjoyed it, over the years. It's been able to supply myself, my family, a decent living. We're doing okay. I'm glad right now to still have a job. Luckily people still need electricity, and I'm glad for that. But I think there is a need, and will still continue to be a need for engineers. I'm not too worried about the engineering field being all of a sudden, a bad place to be working. Okay. So what is engineering? It's basically we apply scientific and mathematical principles and make things that benefit people, be they products, be they processes, be it consulting. The goal of engineering is to benefit people. It's kind of neat to engineer something, to design something, to make something, and see it built, or see the results of your efforts. See what comes from your work there. I kind of generalized here. Electrical engineers, I want to say they work in two major fields. There's kind of power, and there's electronics. In electronics, I've lumped, information systems. That would include computers, control systems, stuff to transfer and process information, and power systems. I used to tell my friends when I was going to school, if you know, in scientific terms, E is the symbol for voltage. Okay, and sometimes E refers to power. But I used to tell people, remember who puts the E in the double E in electrical engineering. It's power engineers. Now again, there I'm a little prejudiced, but I used to tell my friends that went on electronics, if we don't generate electricity, you're not going to run your computers. But if their computers aren't there to help control the power system, we might not efficiently generate electricity. So we all help each other there. So here's some examples of power systems. There's a lot there. Of course, you've got to generate it. You've got to transmit it. Power engineers do a lot in industrial settings. Most big factories or processes have an electrical engineer that has some experience in power that's running the plant and running the process. Of course, motors, even heating and lighting. Lighting. Yeah, lighting is electrical, but heating and lighting. So these are some examples. Now, examples of electronics. You got your telecommunications, computers, controls, the processes of manufacturing. It's amazing what we're doing in controlling, and using electronics anymore. I mean, not wanting to show my age, and I won't tell you exactly where, but When I first started at university, we were the first double E class to not use the slide rule. You know, and I mean, we all kind of chuckle about that. I wish I had my original slide rule that I had back then. It might be worth something. But it's amazing what we can do anymore just with our phone and, you know, a little pocket PC or something. It's just, it's amazing and it's fun. You know, and that's all because of electrical engineers looking for a need or seeing a need and designing something to do it. There's combined systems, you know, between the controls of the different aspects of electrical engineering. You know, elevators or heating and air conditioning. I don't know if you know what a variable speed drive is. It's a motor that can adjust its frequency and its speed to go with the load, and you know, use a lot of those. Medical imaging devices. It's amazing what electrical and electronics are doing in the medical field. So. Okay, well, let's talk a little bit for a minute about a power system. You know, what do I kind of do, you know, with Idaho Power, you know, trying to get the power from point A to point B. This is a typical power system, okay, in real simple form. We have to generate it. Idaho Power has a lot of hydro. We have the same amount as we have, but it's not the same percentage of our generation as it used to be. For example, when I started with the power company years ago, good year, 67% or so, 2/3 of our power could be generated by hydro. Now on a good year, it's, you know, maybe 40%. Load has increased, we've got other generation, and the hydro is not as big a part. Then we have to transmit that power in bulk form, you know, large amounts of power from generation to the different load centers. So there's the great big transmission lines that you see across the country. You know, drive down to Salt Lake and you go underneath a number of large transmission lines that are getting bulk power from, you know, anywhere from Wyoming, from the power plants in Wyoming to here, ties down into Utah. You know, we've got to get that power back and forth, you know, as needed. When we transmit it that way, we transmit it at a higher voltage. You know, some of those lines are 345,000 volts, 500,000 volts. If you know anything, you know, about power, power is current times voltage. So the higher the voltage, the less current or flow you have, you know, running there. So that's why the bulk transmission is, you know, at a high voltage. We usually don't, in fact, we never do bring 345,000 volts into your home. So we've got to do something to it when it gets to the city or the users. You'll come to substations. There's a substation right up here the other side of the freeway on Terry Street called Terry Sub. That substation changes the transmission voltage, which at that point is 138,000, down to 12,500. So then we can distribute it. There's some underground lines that come on down into the university. We might have it go through overhead lines. Underground's a whole lot more expensive. And then it comes to your house, to the school, to the office building. And again, if we're coming in at 12,500 thereabouts, we're still not going to bring that into your home. You don't want your lights that bright. They won't last that long. Okay, so we have to transform it down again. Transformer hanging on a pole or a pad mount transformer sitting out in front of the building, and we step it down to, you know, like the 120, 240 that you use here, and you've got the nice receptacle. You can plug your computer in, and away you go. So that's basically how a power system is set up. And there's a lot to do to run that thing. To build it, to design it, to construct it, operate it, requires a lot of engineering. Here's just a quick overview of, this is the Idaho Power Service territory. We have 5 regions. I'm part of the East region, which includes Blackfoot, American Falls, Pocatello, and I get a run up to the Salmon and Leadore area quite frequently. That's also in our region. But that's the area we serve. And in amongst that, there's some other utilities. There's, you know, you say, well, what about Burley or something? Well, there's some other utilities there. There's Rocky Mountain Power in there. In fact, all the utilities are interconnected, you know, so that we can transfer power back and forth to each other. And if you looked at the whole Northwest, this is just the bulk transmission. This is what it looks like. This is the power lines going all over the place. Some people have said, and I agree with them, that the power system in the United States is the biggest man-made machine in the world. And it is. It's one great big machine when you think about it, all interconnected, and we operate it, and 99.9% of the time the lights are on. I mean, sometimes it's amazing that we can do as good as we do, you know. considering the environment we're in and everything else. So that's a whole nother story we can get into. So what do engineers at Idaho Power do? Of course, there's electrical. You know, we have to operate the power system. You have to plan it. And, you know, everything from planning where the lines are going to go to where the generation is going to be, where you put substations. You have to control it. You know, there's controls engineers. These guys would be more along the electronic side. They'd be more into, you know, computer applications and controlling. The guys that figure out the protection. How did those fuses blow? How did the breakers trip, and when did they trip? You know, so that you just take a portion of the power system off rather than the whole thing when there's a problem there. That's quite a operation in itself. Computer systems and data processing. That's a real big thing. In fact, you hear the term smart grid. I mean, that's a real buzzword. Smart grid means all kinds of things. At Idaho Power, we were able to get involved. We're getting involved with the smart grid, and what we're doing is we're already installing a smart meter system, you know, in the next few years. It started on the other side of the state. It's coming this way. Pocatello will get it sooner or later. Your meter at your house or at your business will have the capability of recording lots of information. And now, with some of the smart grid help that we're going to get, we're going to put a data processing system behind that that will allow the customer and Idaho Power, too, to be able to access that data. The day is coming, you'll be able to hop online, look up at your account, and see how you're using energy day by day, maybe even, you know, within certain hours of the day. That will allow you to maybe say, oh, I want to use energy differently. Because what Idaho Power might do, and some utilities do this already, they might charge you different rates at different times of the day, because it does cost more to run the power system at peak time versus a lower time. That also might be incentive for you to not use power at the peak time, and you can use it at a lower peak time. And then the power company might not have to build as much generation, because we have to have the generation available to meet whatever that peak demand is. You know, a morning like this, when it's good and cold, you know, if I go look at the whole system, I'll see a good spike in how much energy is running down those lines. They're going full bore. And we have to have enough generation available to run that. You know, that brings up the question, you know, well, can't you store energy? You have to use the power as it's generated, basically. I mean, those dams, you know, when those water flows through the turbines, they're generating electricity. When the power plant over in Wyoming, when those turbines are burning coal and turning the, making steam and turning the turbine, it's generating electricity. That electricity has to be used as it's generated. The windmill, when it turns, the windmill has got to generate electricity, and you use it then. So, you know, we have to have enough generation there to meet this demand, even if a lot of times we're down here. So you've got to invest the money here to be able to meet that. So if we can shave those peaks, you know, you're better off there. I'll come back to that in a minute, because I want to say something a little bit more about generation of power and, you know, windmills and green power and other stuff. Mechanical engineers. You got to have mechanical engineers design those power plants. You know, they get involved in that. There's a lot of equipment that runs there. There's a lot of mechanical systems. So there's mechanical engineers there. They get involved in the structural design and construction. You know, as you think of these big power lines that are going across the country, there's some real structural and mechanical design concerns involved in getting one of those up and going. You know, and that also gets, you know, the civil engineers. They get into the line construction, routing, you know, surveying. Then you get into environmental and agricultural things. At Idaho Power, we've got environmental engineers very much involved in things, because when we build stuff, it impacts the environment. So how do we approach that? What do we do to, you know, minimize our impact on the environment and work with the environmental community? Agricultural, that we have an agricultural engineer that works with the farmers. The farmers and irrigators are one of our biggest customers. They're our biggest load in the summer. And if we can help them use power more efficiently, you know, they benefit and we benefit. So we have, you know, agricultural engineers that work there. So you can see, you know, engineers at Idaho Power, yes, the bulk of them are probably electrical, but there's a whole bunch of different types there. What I do, there's 3 engineers here in Pocatello, besides our manager who's an engineer, regional manager is, but 3 of us on staff. I'm what they call the power quality engineer. There's a field engineer and a planning engineer. The planning engineer works with the local planning of the local distribution and what we call sub-transmission system, helping also figure out the load flow and where things should go and how we should hook things up. The field engineer handles the day-to-day operations. He supports the construction side of the company, the operations side of the company in running the system. He handles the engineering analysis and studies. I do power quality and reliability. I'm involved with, I'm actually part of the community relations group. I'm a technical support to that group that works with the customers. I go out and do a lot of testing. I've got a lot of, my kids say I've got all kinds of toys. I do. I got a whole truck full of them. I hook up monitors and we're able to monitor loads at customers' facilities and help them use electricity more efficiently, and or when they have concerns like, hey, when the power goes off, this happens here. I do a lot of stuff on the customer side of the meter, so to speak. I help the customers look and see where maybe they might have some wiring issues or some concerns with their load. Now, it's not up to me to solve that. That's the customer's responsibility on their side of the meter. But if I can help them and get them pointed in the right direction, and also at the same time we're looking at our system to make sure we're connected right, that we're okay there. I do a lot of investigating and diagnosing problems. It's kind of a detective game. It gets to be fun that way. Evaluate and recommend solutions, and a lot of education. Of course, everybody knows how electricity runs and flows. The term I hear a lot of someone says, well, idle power, when you surged, when you had that power surge, that's when I had problems. The only thing that determines how much power is being used by the customers is the customer themselves. When you hook up load, that draws current. That draws, not necessarily a surge, but different amounts of current. Now, yes, when we have problems, when the lightning hits the pole or the squirrel gets across the line or the car runs into the pole, we have to operate the system. So we've got protective devices that'll turn that off and on and check and try to sexualize the system and make it better. Now that's what a lot of people say are surges. So I help people understand how the power system works and see how things are working with their facility. Today I might be helping some little old lady at her house who just doesn't understand how to reset her clocks almost. So, tomorrow we're up here at On Semiconductor or Great Western Malting and helping them solve a technical issue they've got with using the power. So it varies there, and it's fun. Engineers do a lot of different things. I enjoy my job because it allows me, there's always something new. I'm having to dig into the books. I'm trying to have to, get this old gray matter to work again, remember the engineering stuff I've learned, or try to learn some new stuff. So it challenges the engineer in me. I get to kind of try to figure things out. But personally, and everyone's got their own, situation. I could never be one that sits in a cubicle all day long and designs something. So I enjoy the chance to get out, to talk to people, to hook things up, to do testing, get out and about, On days like today, sometimes I have to get out, but if it's really cold, usually there's something I can do in that office and stay warm. I'm not like the crew that has to be out in there every day, keeping those lines going. So I appreciate them. But anyway, but when you think about what we as engineers do, regardless of our discipline, we're just selling our opinion, our educated opinion that we've learned, through schooling, through experience, and it can be sometimes more of an opinion. Sometimes we think, well, everything's exact. And in my job, I'm always investigating and trying to get the facts. And usually when you get the facts, well, not usually, all the time, when you've got the facts, the laws of physics apply, the laws of electricity apply. Ohm's law, for those of you that are familiar at all with electricity, Ohm's law applies, in physics. You can't change gravity, or you can't change the way electrons flow. When you get everything, when you look at all the facts, it makes sense. But you have to put that together, come up with an opinion, an answer to someone's question, and then you got to sell it. You do have to be a little bit of a salesman. Okay? And successful engineers are those who can get their ideas adopted. you know. You have to, it requires much more than just technical skills, and you have to realize that it's not just, I'm going to sit there and always tell people 2 + 2 = 4, Sometimes I have to convince them that 2 + 2 + 2 = 6, If you're trying to tell them that 2 + 2 = 5, then you're in the sell side or the voodoo side, anyway. So what do good managers look for in engineers? First of all, a good solid technical foundation, And in today's world, you need to have computer skills. We're using them all. Can you communicate? Can you communicate with people? Unfortunately, us as engineers have a little bit of a reputation of not being the world's best communicators. Stick an engineer in that cube and just let him design, You can't communicate. Multiplexing. You've got to work with other engineers. You've got to work with the business side. You've got to work, in my business, I'm working with a lot of people, again, even though we're selling electricity, there's a lot of people out of power that don't understand Ohm's law or the technical side of it. Can you explain things in a way that others will understand it? Can you explain the technical side without getting too engineering? And I struggle with that. A lot of engineers struggle with that. As you're talking with people, you want to just sit there and give them all the facts and explain it engineering-wise. Okay, what's your audience? What do they know? How can you explain it to them? And again, you have to work as a team. A little plug for ISU. I'm impressed with the way ISU does their engineering education as you get to that senior year and do your engineering project. When I went through school, my senior project and thesis was all individual, just all me. I've got my son that's mechanical engineering right now. He's working on his senior project, and they work as a team. You have different people. You're not only learning technical things, you're learning how to work with others. Maybe you've got a project that needs a mechanical, an electrical, and a computer science guy. That's the way the real world is, You're not going to know everything, A lot of people say, oh, you're an electrical engineer, you know how to fix a TV and radio. I don't know anything about how to fix a TV. The electronic side, I went power because electronics was too little stuff for me. I wanted power stuff too big I could see. So even within whatever branch of engineering you go into, I'm sure probably in mechanical it might be the same way. As you do things, it's going to be different, but you've got to work as a team. Okay? So, these are some of the tools you'll need. Your technical foundation, computer skills. Again, I've had to learn different computer skills. They didn't have Excel and PowerPoint and laptop computers, when we graduated from the slide rule to the calculator. I know when I say this, my kids say, Dad, you're real old and everything. I can remember one year in college, it was a physiology class of all things. It was a science class to help fill an elective. And my lab partner had a calculator that would add, subtract, divide, and multiply, and had 4 points behind the decimal. We were in Fat City. And he'd paid $300 or $400 for this little one. That you could spend, what, $5 at Walmart or something now for? Anyway, so we've come a long way, and it'll be fascinating to see what you see in your lifetime. Hopefully you'll design stuff that by the time Kenyon and I get a few more years, hopefully you'll help us be able to plug something in our head and help our gray matter work a little better or something. So. Oh, come on, laugh a little bit here. So, dumb engineer jokes, okay? Is this going through the same? Okay. Basically, don't forget these things. Don't forget public speaking. Everybody enjoys English, right? Okay, yeah. Learn how to write reports. Learn how to, write letters. We've got a lot of things helping us, with computers and all now. But, and again, realize that you're going to work with teams. Okay? This is kind of saying some of the same things we've already said here. Okay? But teamwork is important. Okay? Again, remember that what we as engineers do is sell our opinion. Now, that opinion better be based on some good facts, some good knowledge, and some good skills to be able to present it. Okay? Look for opportunities to increase your opinion, the value of your opinion. hopefully, when you get through engineering, you're not going to think, well, I've got that degree, I'm going to, that's all I need. I don't have a PhD. I have a bachelor's, but it has been continual education ever since. Constantly going to classes, to seminars, reading things. In fact, that's one of the exciting things about being an engineer is learning new things, reading. And hopefully, you have that desire, to continually educate yourself if you're going to be an engineer. So, okay. Again, we're designing things and applying it to be used and applied to help people, benefit in their life. And, that's what engineering is all about. And there's, a vast array of engineering. Okay, there's places you can go and look about, different things about what engineers do. I've got a couple down here. Of course, they apply more to electrical. And you could go to IEEE, on the web. There's a number of places. Get a hold of any of us that are out there doing things. Wanted to go back for a minute, as we talk about power and energy, because I know there was some questions again about, storing energy and using energy. I mentioned that, electrical power you have to use as it's generated. I'm excited to see some of the green power things, windmills and that type of stuff. They do have a place. They are part of the generation mix. But still, you have to have some bulk generation. You drive across the state. I was in Boise a week or so ago, and there's more windmills popping up. I don't know if somebody's planting seeds and they're just growing or what, but there's more windmills popping up, and that's great. Let's take advantage of that resource. But when they're not running, they're not generating. And you've got to think about when the bulk amount of energy is needed. With Idaho Power, the 2 peak times we have are real cold days like today. And a lot of times when you get those real cold days, and it's going to get even colder probably, you'll have those high pressure systems sit right over you, and it's still, the air is just stilled. Are the windmills running then? No, but Idaho Power still's got to have some way to generate the electricity. We still got to have that bulk, that base generation to be able to supply it. Same thing on the summer side. Some of those real hot summer days are when the air is just still, So, we use it as part of a mix, and it has to be, takes a lot of thought and thinking as to how to integrate that into the system. I think it's a great asset. I was talking with a person here, that was a few years back when some of those windmills first went in by Buell. I stopped someplace to get gas and something to drink because I was headed to Boise, and the gal noticed that I worked for Idaho Power. She said, "Oh, Idaho Power." She said, "Great that you're putting these windmills in. We just ought to have all windmills and we wouldn't have to worry about power." Well, there was 7 windmills there at the time. I think the total load of those 7, or the total generation ability of those 7 windmills was about 10 megawatts. Okay? 10 megawatts is 10 megawatts. The American Falls Dam that Idaho Power has is 100 megawatts. And it's a small hydro. It's nothing. I mean, you go down to Hell's Canyon, that complex there. Those are some real big hydro units. But, American Falls is 100 megawatts. It's substantial, but tends more towards the small side. So 100 megawatts, 7 windmills were 10. You'd need 70 windmills just to equal 1 American Falls power plant. Now, this brings in the question, and I'm not saying yay or nay what the answer is. How many windmills do we want? And where can we put them, and how do we use them? So it's part of the mix, but it's also got to be in with other things there. So I don't want to at all sound like I'm poo-pooing windmills, because I think the engineer in me is excited. If we can grab energy from the wind and use it, great. Let's grab energy from the sun and use it. But it's got to all work together, because when we go turn those light switches on, we're not saying, let's see, I'm going to pick windmill, solar, or hydro today. I know it's a cold day and the windmills aren't running, so I'm going to do this. And you just expect the power to be there and ready to go. And if it isn't, then I usually hear about it. Okay. Any particular questions? Kenny? Okay? Alternating current versus direct current. Okay? Why do we use AC versus DC? Okay? Alternating current, as you know, it sits there and it's 60 cycles, or it changes, goes from plus 120 to minus 120, so to speak, if we're thinking on it on 120 volts. I mean, we won't get into all the different values, but anyway, it oscillates back and forth there, 60 cycles per second, 60 times a second. Why don't we just have direct current like you have in batteries and stuff, where the current flows in one direction, Well, we talked about that power system, and you had the transformers, okay? Transformers work, through alternating current. As that current alternates back and forth, that magnetic field that changes back and forth is what, makes transformers go, so to speak. And transformers don't work too good on direct current. So, alternating current is the best way to transmit it. Well, I'll have to qualify that too. Alternating current is a way to get it around and change it from, one voltage level to another. Now, there's some losses associated with alternating current that aren't associated with direct current. If you go into electrical engineering, you'll understand some of the different, what impedance and resistance mean and why some of the different losses are there. So, if you can transmit power with direct current, you don't have those losses. Now, here a month or so ago, I went down back home to see my folks in Southern California, and as you go down through southern Utah, or especially you see it through Nevada into California, there's a great big old line there, and it's a direct current line. It comes from the Intermountain Power Project in Utah on down to Southern California. So you're transmitting hundreds of miles, and you don't have the losses, as much loss in there with that direct current as you would with alternating current. Now the trick you've got is you've got to have a converter circuit on the front end and a converter circuit on the other end to change it. When it's generated, there at that Intermountain Power Project, it's a big turbine turning, it's generated at AC, they convert it to DC, ship it on down, and then they have to convert it back to AC on the other end. So the economy has to be that it's worth the distance, it's worth the cost, and it's worth the cost of the converter circuits or the inverter circuits on either end. Who was it? Edison and Westinghouse, was it, that had this argument years ago about which way? AC, yeah. Well, I mean, on the bulk power system, AC works pretty good, and everything, of course, now is designed to work on AC. But what happens to AC when it comes into your house and you hook it up to your laptop or to your boombox or whatever? Is that AC that's flowing through the digital circuits of your computer, that's flowing through the speaker and booming out? It's actually DC. You've got a converter circuit in there to change it to DC. Also to change the voltage. So there's some economies of scale, there's, reasons why you do it one way or the other. Does that kind of answer the question? I mean, help understand that? We don't just toss a coin and say, well, AC or DC today, which way do I feel? Engineering is a good profession, It's a challenging one to get through school, I don't know how it is now, but I used to have friends that were over on the business side, in business school, and I was in engineering. Those guys were over there getting all these A's all the time, Engineering, are you ever happy to pass a class? Maybe? Just glad to get through it. And I shouldn't say it that way, because hopefully you all work hard and you all get straight A's through engineering, But it seems like professors in engineering believe that C was an average student. I don't know. Do you grade that way now, Kenyon? No? Yeah. So, I mean, there were a couple classes that I was tickled pink to get through, And, but after I've been out a number of years, and I look back at some of my stuff that I did there, and I have a whole lot better intuitive feel for it and understanding for it than I ever did when I was in college. And that'll come. That'll be there. I used to be jealous of the people that had been out in the workforce or had some military training or something and had used, a lot of this stuff. And they'd get into class and things made sense to them that to me, I was still trying to get my mind around, Experience is a good part of your education, and a lot of that comes afterwards. If you can get some experience now, if you've got an opportunity, a job or a internship or something to do that while you're going through school, great. That's going to be a plus for you when you're hunting for jobs. So, but don't worry if you don't all understand it. I'll never forget when I graduated, came here to Pocatello, and they wanted the engineers to get some experience actually writing jobs and designing systems. And they sent me out to Engr and told me this new customer wants to hook up to power. And I looked and go, I don't even know what this stuff is. I felt, and I had to get one of the guys from the crew who, didn't have an engineering education but had been around it for years. And he put his arm around me and helped me through it, and we got through, and so I guess that's also a plug. Just because you're an engineer, don't have the attitude that you know it all and you're better than the guys that don't have the engineering education. Use those technicians, use those people that have been out there. Work together with them, teamwork there. So, anyway, questions? They do at times. A lot of times, usually they're in internships are in Boise. We used to have some here. They haven't had some in Pocatello for a long time. But I'll have to admit, with the way the economy's gone in the last year, so we've kind of held back a little bit. I would expect that down the line there would be some. I would be more likely to see stuff in Boise. The problem is, like I said, we've got 3 engineers here in Pocatello. Boise is where headquarters is, where all the support groups are. There's a myriad of engineers there, so there'd be more opportunities there. But if you are ever interested in anything like that, get a hold of us. Let's see what happens. A good time to be thinking about that is about the first of the year for the coming summer, or even maybe earlier in the fall, or before the first of the year. But I'm not sure what we're going to have next summer, if we're going to have anything next summer. But there are things at times. To who? Oh, okay. Yeah, and we need to do a better job, and I feel a little guilty on it. I need to do a better job of getting idle power information ISU. I mean, there is life outside the great state of Ada in the Boise Valley. ISU is a good school, so, okay. Thank you.